Hey Wildcats, everyone at journal page 55, graphing more complicated rational functions. Example 1. Select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph's line asymptote by dividing the numerator by the denominator. Also state the function's domain and range using inequality, set notation, interval notation. If your graph indicates that the function has a maximum or minimum value using Desmos to find the values to the nearest hundredth when determining range. All right, let's take a look at f of x equals x minus 3 divided by x plus 3. Find the vertical asymptote by setting the denominator equal to 0. So we set x plus 3 equals to 0, so we subtract 3 from both sides, x equals negative 3. So there is a vertical asymptote at x equals negative 3. Okay, now we're actually going to turn to the next page, and let's go ahead and graph that vertical asymptote. Okay, so we have a vertical asymptote at x equals negative 3. Let's come back. Now we're going to divide. Now you ask yourself, what do you multiply x by to give you x? The answer to that is 1. The numerator and denominator have the same degree, and the leading coefficient of each is 1. So there's a horizontal asymptote at y equals 1. And let's go ahead and graph that now. Okay, so horizontal asymptote at 1. Okay. Now find the x-intercept by setting the numerator equal to 0. So we set that equal to 0, add 3 to both sides, x equals 3. So the x-intercept is that x equals 3, so that's 3, 0. So let's go ahead and graph that point. So 3 zeros right here, and since the point is right there, we know that the curve is right there. Now, all we need to do now is graph this in Desmos to find a point here to find our curve, okay? So, divide x minus 3 divided by x plus 3. Coming over here. Negative 5, 4, okay? So, negative 5, 1, 2, 3, 4. So that means our curve goes along like that. Okay. Go ahead and finish up the graph. And let's take a look at the next example. Oh, wait. Almost forgot. Let's look at the domain and range, okay? Now, the domain, okay, if we graph x equals negative 3, you can see the domain goes from it's less than negative 3 or greater than negative 3. It doesn't include negative 3, and it goes from negative infinity to negative 3 or negative 3 to infinity. Okay? Now let's look at the range. Y equals 1. So you can see that y is less than 1, y is greater than 1. It doesn't equal 1, and it goes from negative infinity to 1 and 1 to infinity. Okay? So that explains the domain and range. All right, let's take a look at the next example. Example 2. Select the graph of the given rational function. If the degree of the numerator is 1 more than the degree of the denominator, find the graph's slant asymptote by dividing the numerator by the denominator. Also state the function's domain and range using inequalities, set notation, and interval notation. If your graph indicates that the function has maximum or minimum values, using Desmos to find those values to the nearest hundredth when determining range. All right, so let's take a look at the function. Okay. When a rational function has a factor in the denominator that is also in the numerator, a point of discontinuity occurs at the value of x, for which a factor equals 0. Okay? What they're talking about is right here. This divides and becomes 1. So we're going to set that equal to 0. So we add 2 to both sides. So x equals 2. On the graph of the function, a point of discontinuity appears as a hole. So there is a hole at x equals 2. right? Step 2, find the vertical asymptote by setting the denominator equal to 0. So we do that. So x plus 2, 0, subtract 2 from both sides. So x equals negative 2. So there's a vertical asymptote at x equals negative 2. Now, let's go ahead and graph x equals negative 2. Okay, so we have our asymptote at x equals negative 2. Now, we talked about a hole. Let me actually take a step back. I'm going to go into a little bit more detail about the hole. We talked about the x value alone in, I think, one of the previous videos. But now let's go into more detail about the hole as a point. So we're going to plug 2 back into the function. So f of 2 equals negative 3 times 2 divided by, we're ignoring this because this is 1. Okay, so we're plugging in 2 everywhere there's an x. And divided by 2 plus 2. So negative 6 divided by 4. Let's go ahead and get that as a decimal. So negative 6 divided by 4 at negative 1.5. So there's a hole at 2 comma negative 1.5. And so let's go ahead and draw that. Okay. So 2, negative 1.5. There's a hole right here in the graph. Okay. All right. Now let's take a look at the next part. All right, step 3. Find the x-intercept. So we set the numerator equal to 0. So we divide by negative 3. So that divides and becomes 1. So x equals 0. So you have an x-intercept at 0, 0. Let's go ahead and graph that point. So point at 0, 0. Now we don't have the horizontal asymptote, but we can find that using Desmos. So let's go ahead and graph negative 3x divided by x plus 2. Now you can see here something's happening here, and it looks like negative 3, so let's take a look. Y equals negative 3. Yep, so our horizontal asymptote is at y equals negative 3. So let's go ahead and graph that. Okay, so we have a horizontal asymptote at y equals negative 3. Okay, so we have 2 points here, so we know our curve goes like this. Okay, now we need to find a point here so we know where the curve is. Okay, so let's go here and close negative 4, negative 6. So let's use that point. So negative 4, negative 6. And since we have a point here, we know our curve goes like this. Okay, let's take a look at the next part. Okay, now to understand the domain and range, let's take a look at the graph. Now, we know we have something going on at x equals negative 2, and we know we have something going on at x equals 2. Okay, now you can see here that it goes x is less than negative 2, or it's from negative 2 to 2, but there's a hole there, or x is greater than 2. Or you can see that it doesn't equal negative 2 and it doesn't equal 2 because that's where your hole is, okay? All right, and then we know it's coming from negative infinity to negative 2, negative 2 to 2, or 2 to infinity. Okay, so that's your domain. And let's take a look at the range. Y equals negative 3. So we know that y is less than negative 3, y is greater than negative 3, y does not equal negative 3, and we go from negative infinity to negative 3 and negative 3 to infinity. All right, let's go ahead and finish up your notes example, start working on your assignment, and have a wonderful Wildcat day.